I've built a bunch of Raspberry Pi NASs, from a little tiny all-SSD NAS to the biggest one on Earth, the Petabyte Pi project. But the Pi 4 and Compute Module 4 were just barely adequate. I could never get even 100 megabytes per second over the network, even with SSDs. The two most promising projects, the WireTrusty SATA board and Radxa's Taco, were both dead in the water. They launched right before the Great Pi shortages, when you couldn't get a Raspberry Pi for love or money. But the Raspberry Pi 5 is here now. It's faster, it has PCI Express, and best of all, you can actually get one. Yeah, it's a little more expensive than the Pi 4, but with off-the-shelf 4-bay NASs costing $300 and up, could we actually build a Pi NAS for less? And would it be any good? Well, today I'm gonna see, and to do it, I'll use this tiny SATA hat that Radxa sent. This costs $45 and it's already shipping. Add a 12-volt power supply, a Raspberry Pi 5, a fan and micro SD card, and we have a tiny NAS for less than $150. But will bottlenecks kill this thing like they did with the Pi 4? I mean, the Pi 5 only gets a gigabit. Those other NASs can do 2.5. And they have hot swap drive bays, and vendor support. So yeah, comparing just on price alone is silly. There's always gonna be trade-offs when you go DIY. But this thing should have a lot fewer compromises than the jankier builds I did in the past. At least, I hope. And 2.5 gig networking? I might have a fix for that. I'm gonna put this thing together and see if it could be the ultimate Raspberry Pi 5 NAS. I do not know exactly what tools will be required, and I don't know what's in the box. Hopefully it includes everything I need. But Radxa usually does a pretty good job including all the little bits and bobs you need for this. Looks like it includes this extra cable. This is, after all, the Penta SATA hat, so 5 SATA connections. I have 4 drives here, but you can add on another one using this strange external, I guess this might be eSATA or something, but it has SATA and power from this board. Something important to think about is how you're going to supply power to it. I know some people in comments have mentioned, oh, you need to supply power to the Pi and this board, but no. I believe that you can just power this board through the 12-volt barrel jack or through an ATX Molex power supply here. So if you have it in a PC case or something, you could do it that way. And this will supply power to the Pi 5 through the GPIO pins. This should be able to provide adequate power as long as the power circuitry on here is good enough to take that 12-volt signal and give a clean 3 to 5 amps on the Pi's 5-volt rail. Now this doesn't have the normal PCI Express connector that you see on the Pi 5. So the Pi 5 has this little guy here. This has a much larger connector with more pins. That could be an interesting thing. I believe that they have an adapter for it though, so yeah, here it is. So this is called an FFC, or flat flexible circuit board, and it looks like they've included 2, which is nice because these little connectors are a little bit delicate. You can see how thin they are. They're kind of, they're kind of like paper thin. But these are flat flexible circuit boards, or FFCs, and they connect from the Pi's PCI Express connector here over to this guy here. And the GPIO pins over here are going to provide power to the Pi. At least that's my hope. There is a getting started guide on here, but I'm gonna YOLO this thing and see what happens. One important thing whenever you're doing these is make sure you get the connector seated all the way, and it should go in pretty easy. If you're pushing hard, then you're gonna break the cable, so don't do that. If you're pushing hard, you might need to pull this little connection up, and always do it on both sides so that it doesn't come off. Because if it comes off, it might break, and then you would not have a way to hold the cable down. You push down on this little top part, and this cable is now affixed to the Pi very well. And then I'm going to plug it into here. So it looks like it goes like this. The funny thing is these kind of connectors are often used inside of cameras and other things that are put together at factories. And they're very careful. They have their methodologies. They even have tools to help with it. When you give these things to people in the general public, like you and me, we tend to break our first one. So I guess it is a really good idea that they included a second one here. They probably have some screws too. Let's check. Yeah, there's a little kit full of screws here. There's some standoffs and things. And then now I'm going to put this in. I'm going to carefully put this over and plug in the GPIO pins that provide power, but that fits nicely together. There is a connector here for an OLED and fan control board that sits on top of the hard drives at the top. They don't have that available yet. I think they used to make it. I don't know if they needed to revise it for this or what, but I asked about it and it's not yet available. So it'd be nice to have that, especially, these are not that hot of drives, but if you use hard drives, if you use 2.5-inch hard drives, then those can get pretty toasty, and it's nice to have a fan blowing air over them. I just realized I don't have any fan on the Pi itself, and I probably should do that because it could get pretty hot and toasty inside here. Let's get our little active cooler here. I hope this will fit. I don't know if there was a warning against using this, but the Pi does need some sort of cooling, whether it's a heatsink or a fan. And there's no fan built into this. It'd be cool if there was a little fan under here, or an option for one, but it doesn't seem like that's the case. Okay, please still fit. Looks like it will fit. Oh no, you know what? The barrel plug is just touching on the top of the heatsink. There's literally it's just three of the fins on the heatsink. You know what I might do? Might see if I can bend those off. Take this back off again. I'm gonna pull this connection off. This is a terrible idea. I would not recommend doing it. Just bending this back and forth. There's one. Shouldn't affect the performance that badly. I removed the middle portion from the middle point up of these three little fins on the heatsink. And there's a side view of it. You can kind of make it out. It's kind of hard to make out, sorry about that, but let's get this all back together now and see if it fits. Okay, this time, if I go down, it can go down all the way, and look at that. That's just enough clearance. As long as it works in the end, it's all good. I use this huge guy, just give these a little snug. Generally I'd use a nut driver for this, but this works in a pinch, literally. My top-down recorder decided to corrupt the rest of the video, so I lost all that footage. But in that footage, I mentioned the board uses the JMB585 PCIe Gen 3x2 controller, which means even if we uprate the Pi 5's bus to Gen 3 from its normal Gen 2, we'll miss out on a little bandwidth. And also the kit comes with two side supports that hold all the 2.5-inch drives together, though there may be a case available at some point in the future. They actually had one in the past when it was sold for the Rock 4 or the Pi 4, I think, but I'm guessing that they'll have to make another batch if they get enough interest in this new version of the Penta SATA happen. Okay, so everything is put together now. It's all looking nice, and I think there'll be enough airflow. There's holes in the sides, holes in the middle, so enough air will convect through for these drives at least. And I have a 5 amp 12 volt power supply. This should be adequate for these drives and the Raspberry Pi 5. I'd budget maybe 3 to 5 watts per drive, or if you have 3.5-inch drives, maybe a little more, and you might want to get an 8 amp or maybe even 10 or 12 amp power supply. But definitely don't use like a 2 amp power supply and expect this to work. It's going to have all kinds of issues. I also have Raspberry Pi OS 64-bit Lite version, and I might try Open Media Vault. I'm going to take the micro SD card and put it into the slot, and then I'll grab this power adapter. Now, another reason why I'm over at the desk is I have my little, this is a Zigbee, Third Reality Zigbee outlet that has power measurement built in, which is very handy for testing. I'll go ahead and bring that up on here. If I go to Home Assistant, and then go to power, you can see that right now there's 0 watts because there's nothing plugged into it. Power is going to come in. It looks like they wanted to align the power with the USB-C port. Not that that matters. First I'm going to plug in network, and I'll plug in power, and we'll see what happens. Hopefully no sparks. All right, I have a green light on the board, and the Pi is booting up. Power usage is up to 14.2 watts. At boot, and now the Pi is doing its reboot, so it's going to reboot a couple times this first time that I turn it on because it expands the file system to fill up the micro SD card. all that kind of stuff. So we'll fast forward a bit until it's all booted up, and then we can log into it on the network and see if it's actually working. I don't see any lights. There's just one green LED on the board over here, but I don't see any other lights. So I don't know if there's lights per hard drive. So I'm going to log into it and we'll see what we can see. SSH pi at pi-nas.local. There it is. And if I say lsblk, hopefully we see those hard drives. No, we're not seeing them. Let's try lspci. And I'm not seeing the device at all. I don't see any errors in here. Let's go to the URL on this box and see if there's any other tips that we're missing. rock.sh/Penta SATA hat. Penta SATA hat. So we did that. We did that. Oh. So maybe I should actually do that. Let's try that. Go in here. You'd think it would do it automatically, but it does not. So we're going to enable PCI Express, save and reboot. So save that and reboot. So let's check again. There we go. We have 1, 2, 3, 4 hard drives. And if I say lspci, I can see the JMicron SATA controller. Now, right now it should be PCI Express Gen 2. We can check that with sudo lspci-vvvv. This is going to give us all the information about PCI Express devices. And if I go up to here, this is AHCI, that's the kernel module for the SATA controller. And we can go up to the top section. See, it's JMicron JMB 585. And if I go down to link capabilities, it says speed 8 gigatransfers per second, width by 2. That's PCIe Gen 3 by 2. But the status says it's 5 gigatransfers by 1. So definitely less bandwidth than the chip is capable of. So I'm going to try PCIe Gen 3, and I can do that following my own guide. If I go down here, turn that on like this, and reboot, and we'll see if it gives us Gen 3 speeds instead of Gen 2 speeds, which would give us the maximum performance that we can get on the Pi 5. I have 4 drives that have nothing on them. I'm going to try, we should probably just benchmark the drives first in like RAID 10 just to see what the maximum speed is, or maybe even RAID 0. So let's do that. That'll take a couple minutes, and we have blinking. So you can see that the LEDs actually do work. I didn't see those when I was looking earlier, but it has some LEDs and you can see them blinking when the drives are accessed, so nice job. I should check, it does feel a little bit hot. In Infrared, I found them at CES, and they actually sent me home with a couple goodies. This is the P2, and it's the reason why I wanted them to send me home with one to test was it has this snap-on macro lens that you can see individual resistors or things on your PCB very close up, which is kind of cool. But their software is a little bit iffy. Not the best software that I've used for IR cameras. But the camera itself is really good quality and works better than my old Seek thermal. But let's check the temperatures on here. And it looks like the drives themselves, well, they're a little bit reflective, so we might not be seeing the actual drive value. But the board is up to 50 degrees or so. The SATA controller's down there. It looks like it's the hottest part of this thing. And it is getting up there to 60 degrees Celsius, so it might be good to have at least an active fan blowing down on top. Oh, there's the cold soda can, 16 degrees Celsius. And there's the hot SATA chip. So I'm going to put this cover on. You can see up nice and close. If I get in there, yeah, we can see that the chip itself is 60 degrees Celsius. So it's pretty toasty in there. Yeah, I would definitely do a fan or heatsink on this if you're going to deploy this long term. Another fun thing with thermal imaging is you can see all kinds of fun details. Like you can see that this is where my hand was resting, and if I just put my hand on the table and take it off, there's a handprint. And apparently this little screen on here also generates a teeny tiny bit of heat. And now it has my fingerprint on it, which is also warm. Looks like the formatting is finished, and what's our next step here? Mount the array. Okay, mount RAID 0. So now let's do a disk benchmark on it. And we'll run the disk benchmarks and see how fast this array can go. Okay, here goes FIO. Hey, that's not bad at all. 850 to 60 megabytes per second. And that's megabytes, so let's see how fast it was in megabytes. Almost 900 megabytes per second across all 4 drives in RAID 0, of course. But random reads of 687 megabytes per second and random writes of 758. And then we have 4K block size, 44 megs read and 152 megs write at 4K, which is not bad at all. I'm interested in seeing, I think what I'll do is I'll just put a Samba share on this and we'll see if we can saturate a 1 gig connection continuously. Restart Samba and create a password. Now I should be able to connect on my Mac, pi-nas.local. We'll do the shared directory. Here it is. So I'm going to copy over a folder with all of the footage of the build. It's 100 gigs. And let's check this out. Let's see how fast it is. That is line speed. 110 megabytes per second is pretty typical. Let's see if it can keep up that data rate. I can smell that like slight off-gassing here, so I do think that I would put some sort of cooling on here just for that JMB 585 chip. On my other NASs, over 1 gigabit, you can just hammer it and it'll stay 110, 150 megabytes the entire time. This is a lot faster than the Pi 4 NASs I've set up before though. And we'll just let the screen recorder keep going at 18 minutes and we'll just keep moving. While that's copying, I want to take a brief opportunity to tell you about OpenSauce. OpenSauce is going to be June 15 to 16 in San Francisco, and I'll be there. I'll be there along with a ton of other creators in the maker areas, electronics, hacking, all kinds of fun things. If you want to go, there's a way that you can get in for free, and you can come to the party that's beforehand where all the other YouTubers and everyone will be present. If you want to do that, you can apply to be an exhibitor. They have tons of space for exhibits this year. It'd be really cool to see your project. So if you want to do that, go to opensauce.com and apply to be an exhibitor. Otherwise, you can also come as just a normal person who's not exhibiting things too. So hopefully I'll see you there June 15 to 16. If not, I will definitely be posting some things on Twitter and maybe something on YouTube, I don't know. So make sure you're subscribed. It copied everything over to the Pi. Now let's check the read speed. I'm going to copy it back into a different folder on my local computer. And we'll see if it can give me 110 megabytes per second. Oh, look at that. It's giving me 122, which is a little faster than the write speed. And you can see that the drives are reading pretty much flat out right now. I don't know if that'll fill up the cache, but you can see that the data is flowing a lot more smoothly coming off the Pi than writing to it. So there are some bottlenecks. I don't think it's Samba, and I don't think it's the drives themselves. I think there's a bottleneck somewhere in the Pi's kernel or something when it's writing through, because I had that problem on the Pi 4, but on the Pi 4 it wouldn't even hit like 120 megabytes per second all the time. But reading, that's not an issue at all here. We're cranking at 120 megabytes per second. I deleted everything off of there, and it looks like obviously read speeds are much more consistent than write speeds. But I'm going to try something else that I mentioned at the beginning of this video. What about 2.5 gig networking? Now, Pineberry Pi makes the HatNet 2.5G. This is a 2.5 gigabit hat for the Raspberry Pi 5. But you'll probably already notice there's a problem. It has one PCI Express input. There's only one PCI Express connector on the Raspberry Pi 5. How do we solve this problem? Because this needs that, and I want to put it on here too to see if I can get 2.5 gig networking. Well, I can try the Hatbrick Commander from Pineberry Pi. And yes, they sent me these things. I would be buying them myself anyway, but I'm going to disclose that Radxa sent me this and Pineberry Pi sent me this. I'm testing these things out to see if they can work together and do some crazy things. But Pineberry also sent me all of these extra cables of varying lengths. One thing that can be a problem with when you start connecting multiple things together is the PCI Express signaling. So I'm going to try to use the shortest cables I can for these experiments. But I'm going to basically put this, which is a PCI Express Gen 2 switch, off of the Pi's bus. and then connect one connector to the SATA drives and the other connector to the HATnet 2.5G. The downside is this is going to make everything be PCI Express Gen 2 speed instead of 3, so I wouldn't be able to get 800 megabytes per second on these hard drives. But on the flip side, this is 2.5 gig networking, and if we say, let's say 2 gigs for networking and 2 gigabits for the hard drives, we might be able to do that to almost saturate 2.5 gig network if the Pi 5 can support that. I don't know if it can or not. I don't think it will be able to, but we'll see if any of this even works. It might also not have enough power. I don't know. But I'm going to unplug this. Okay, we got that connector out of here. There is some risk here. If we are mixing these cables from different vendors and connections, there's a little risk that something's going to go wrong, but hopefully that doesn't happen. It's definitely not my finest work. There's an LED on here, and I see a light on the switch, and there's a power LED on the hat brick commander, and there's lights on here. Let's see if this is actually going to work. LS PCI. Hey, look at that. So we have the switch here, we have the SATA controller here, and we have the 2.5 gig controller here. Let's do IPA, and we have an IP address on that. So let's do iPerf test. Now we're getting 2 gigabits. It's not 2.5 gigabits, but it's not nothing. So coming back only 1.6 gigabits, that's not horrible. It's still more than a gigabit. This is probably going to get 2.5 gigabits if you connect it straight to the Pi. I think that some of the overhead comes out of that packet switching that is running to the drives as well. So if I say LSBLK, we still have the drives and they're mounted. So we'll see if we get any faster write speeds. It's doing 110, 117. That's about the same as what we were seeing before. So we're not getting faster than a gigabit over the 2.5 gig connection, at least for writes. I do see a few peaks up to about 125 megabytes per second, so better than a gigabit. And it's interesting, the overall rate seems a little steadier with the 2.5 gig. Maybe the Pi's internal controller is a little funky, but I don't know. But it's giving us a little bit more on the write speeds. I'm really interested to see the read speeds though. Hopefully we can get more than 1 gigabit. Let's check. There we go, 217 megabytes, 250 megabytes per second. That's more what I'm expecting out of a 2.5 gig connection. So this can put through that data. It's interesting. I think it's pulling from RAM because I don't see the drives blinking at all here. It's probably copying all this data from RAM, and now it's hitting the drives, and you can see it dips a tiny bit there, so down to 230 megabytes per second. So Linux usually caches files on the RAM as it's copying them back and forth, so that if you have a file that you're accessing a lot, it's a lot faster. But now that it's hitting the drives, it only dipped down 10 megabytes per second, so that's not bad at all. So for a read-heavy NAS, this isn't looking like that bad of a setup. Now that I know that everything is going to work on here hardware-wise, I think it's time to put OMV on here and see how that runs. I haven't used OMV 7 yet, so this will be new for me. I don't think it's that much different than OMV 5 and 6, but let me grab this script and go over here, and this hopefully will just work. I'm going to SSH into the Pi and just paste in their script, the installer, and here it goes. Let's check power consumption. So during the install it was using between 8 to 10 watts. And it looks like the baseline for this build is 8 watts with the 2.5 gig network adapter and everything else. But let's go to pinas.local. And does this work? Maybe I have to use the IP address. Let's try that. Well, there it is. I guess it was still booting up. Okay, so that was not the problem there. So admin and Open Media Vault are the password. Logging in. There it is. There's no dashboard. That's okay. Storage is where we should see our disks. They should show up. Yep, 1, 2, 3, 4. All of them are 8 terabytes. And I want to create an array. File systems. Is this where we create it? Create and mount a file system ext4. But I want to create a RAID array. How do I create a RAID array? Am I totally missing something? I thought there was a thing over here for creating RAID, but I don't see it anymore. What does this say? See, this has RAID management, but I'm not seeing RAID management anywhere. Do you see RAID management anywhere? And we could try ZFS instead of RAID, but that's instead of like mdadmin RAID. So we can try it out on Open Media Vault. I've never tried it on OMV before, but we'll see how it works here. I like this little end of line here. I guess a nod back to Tron, the 1974 version. And we'll do RAID Z1 since we have 3 drives. A RAID Z1 will use 1 drive, the equivalent of that, for parity data. That way I could lose one of these 4 drives and all the data would be intact. But here we go. It says pending changes, 21 terabytes available. Let's apply this. So now the tank should exist. Compression is on. I don't know if I would need compression on, but I'm not going to mess with any of that right now. If we go to pools, is there anything else I can do? Tools, what do we got? So you can scrub it. I don't know if it automatically scrubs in here, but it gives us the pool information. That's nice. So this is it's a good interface. It's not maybe not the best thing ever, and I don't know if it comes with schedules and things by default, but it'd be nice to have a scheduled snapshot and pool scrubbing scheduled. That might be something that you configure under scheduled tasks. Yeah, so you'd have to do some of these things. You'd have to add your own scheduled tasks. It'd be cool if that added some things by default, but I can see why they don't as well. But now let's add a file system. So we have one, tank ZFS. I'll add shared under tank, shared, and we'll just set everyone read write right now. Save. Turn on Samba, enabled. 10.0.2.211. Okay, so it wants me to use the IP. And there's our shared volume. So let's, I'm going to copy some stuff over to it. I have this folder has 100 gigabytes. So I'll do that. And here it goes. So it seems similar to the copies that we were getting with RAID 0. It's interesting. It goes a little bit faster sometimes than those copies were. So I'm wondering if ZFS's caching is actually helping here. So far, I'm pretty impressed. I think read speeds are where this wins. Write speeds are where this loses a little bit, because you're not going to be able to get full 2.5 gigabit networking on that. But it's better than I was expecting. And the big win for me, besides the fact that this can be made smaller if we kind of reconfigure these boards, the big one is the power efficiency, because right now we're using 15 or 16 watts. Typically, the other NASs that I've built using pre-built NASs, they use 10 to 20 watts idle, and they use 25 to 30 watts when they're doing a lot of stuff. So this little guy is only using 16 watts, doing the same amount of work, which is probably about half of what most pre-built NASs would use. On the flip side, if you build a NAS with the RK3588 chip, you could probably get even more efficient and more speed. So there's a couple boards out there that are interesting that I might take a look at some point. But the nice thing is all of this is all really well supported. Like the software, just click some buttons and you have everything working. I haven't always had that same kind of experience when I'm using the Rockchip boards. Some of them are getting pretty good though. I'm going to go ahead and let this write finish, and then I'm going to do a full read of that 100 gigs of data, and we'll see where we end up. At the end of the copy, it looks like the system used 22 watts for a little while it was doing some sort of processing. I don't know what ZFS was doing there. Maybe that was part of the compression. I don't know. It's a lot of power to use at the end there. The actual performance was interesting. After that initial part, where it was faster than RAID 0, it actually slowed down to a tiny bit slower than RAID 0 over that long rest of the copy. And that's why it's good to use a large file to test the actual performance of your system, because especially with ZFS, it's going to cache a lot in the beginning in RAM, and that throws off how fast your actual disk array is. But the CPU usage was not too bad. Power consumption was down around 8 to 16 watts throughout the whole copy. But in the end, the file copy was 74 megabytes per second with ZFS in RAID Z1, and it was almost 100 megabytes per second in RAID 0. Now that's for the writing, which is always going to be a little bit slower with a setup like this. Read speeds for both are practically the same. It's just basically line speed. It's not hard at all to do the reads. So this is a little embarrassing. All those conclusions I have are based on the fact I was benchmarking this all on a Mac, and I switched to my Windows PC, and I was able to get almost line speed for 1 gigabit file copies writing to the Pi, and 150 megabytes per second writing over the 2.5 gig network. So that changes my perspective a little bit on it, and I think the biggest takeaway is don't use a Mac for benchmarking network file copies, even if it has 10 gigabit networking and everything else on it seems to be fine. Mac OS for some reason is not great with file copies, and I have a whole blog post and I have more details in the GitHub issue linked below, but let's get back to the video. It's not inconceivable to build a system like this. All in, this one is still under 200 bucks total, including all these extra boards and things. So, but it always goes back to DIY means you're responsible for the software, you're responsible for maintenance and updates and all that kind of stuff. Anyway, that was a fun experiment, and I plan on doing some other fun experiments now that I have this little board here that lets me split up PCI Express lanes, and we'll see how we can bend the Pi 5's PCI Express bus. It'd be really cool to see a Compute Module 5 expose even more, but we'll see what happens whenever that comes out. I know that was a big change from the Pi 4 to the Compute Module 4. It gave us PCI Express. Now we have it on the Pi 5, but I think we might be able to do more in a Compute Module form factor, but we'll see. Until next time, I'm Jeff Geerling.